Okay, this is lesson 21 for course 2, 7th grade math. So this is the title of your lesson, Prime and Composite Numbers and Prime Factorization. So let's write down the title and the date and lesson 21 and we'll get started. Okay, so I'm going to tell you what I need you to write. First, let me just read to you. Remember that the counting numbers are the natural numbers and they start with 1 and go on and on forever, 1, 2, 3, 4, 5, and so on. The counting numbers are either prime or composite, and that's what we're going to talk about today, prime or composite. A prime number, you want to write this down, a prime number has exactly two factors, 1 and itself. So write that down. A prime number has two factors, 1 and itself. And a composite number has 3 or more factors. Remember, factors are the numbers that multiply to get that number. In the following table, we have the factors of the first 10 counting numbers. So we have the factors of 1, the factors of 2, the factors of 3, factors of 4, factors of 5, factors of 6. All of the ones that have only 2 factors, so that would be 2, 3, 5, and 7, those are called prime numbers. If they have more than 2 factors, then they are called composite numbers. 1 is not prime or composite. So make sure you know what a prime number and a composite number is, and make sure you know that 1 is not prime. That's one most people get confused on. All right, let's keep going. All right, so we see that a prime number is a counting number greater than 1 whose only factors are 1 and the number itself. All right, so let's see. Example 1, we want to make a list of the prime numbers that are less than 16. Prime numbers that are less than 16. So we already said that prime numbers start with 2 and 3 and 5 and 7. So we have those already. Those are less than 16. So now we need to think of the next numbers that are only divisible by 1 and itself. So we think of 8, no. So 8 is not prime. 9 is not prime. 10 is not prime. 11 is. So we'll put 11 up there. 12 is not prime because you can divide by 2. 13 is prime, so we'll list it up there. 14 is not. 15 is not. So these are the list of the prime numbers that are only divisible by themselves and 1. Example 2, write this down. They want you to list the factor pairs for each of these numbers. Write that sentence. List the factor pairs for each of these numbers, and then which one of these is prime. So 16, the factor pairs, that means numbers that multiply to get 16. So 1 and 16, and 2 and 8, and 4 and 4. So these factor pairs multiply to get 16. So is this prime or composite? That would be composite. Look at 17. Is 17 divisible by anything? 1 and 17 will make 17, but I can't think of any other numbers that would multiply to get to 17. So that means that number is prime. 18, 1 and 18, and 2 times 9, and 3 times 6. And I can't think of any more, but because I have all of these, I know that that number is composite. All right, let's do a few more examples. All right, this says, write this down, example 3, list the composite numbers between 40 and 50. So write that sentence down. List the composite numbers between 40 and 50. And here we have the counting numbers between 40 and 50. So these are the counting numbers, but we need the composite numbers. So we're going to look for numbers that are divisible by more than 1 and itself. So if I look at 41, there are no numbers that I can think of that will go into 41. 42 is divisible by 2, so 2 times 21, 6 times 7, so that has to be composite. 43, no, there are no numbers that go into 43. 44, yes, because I can do 2 times 22. or 4 times 11. 45, yes, it's composite because I can do 5 times 9. So if you can think of any other numbers that multiply to get that number besides just 1, then that's going to be a composite number. 46, yes, it's divisible by 2. 2 times 23. 47, no, I can't think of anything besides 1 that goes into 47. 48, 6 times 8. 4 times 12. And then 49, 7 times 7 is 49. So these would be the composite numbers: 42, 44, 45, 46, 48, and 49. Okay, let's go on to the next. All right, our goal next is to be able to write the prime factorization of a number. So write this word down, prime factorization. We write a composite number as a product of prime numbers. So that's what prime factorization is. Writing a number as a product of prime numbers. So here are the prime factors of the first 9 numbers. All right, so 2 times 2. Notice that 2 and 2 are prime. 3 times 3, 3 and 3 are prime. 2 times 7 makes 14, that's prime. 2 times 3 is 6, that's prime. 2 times 5 is prime. 3 times 5. So factors, these factors are all prime numbers that when you multiply them all together, you get the composite number. So we're going to practice that. All right, there are 2 different methods for doing a factor tree. For finding prime factors. So 2 commonly used methods for factoring composite numbers. One is called the factor tree, and the other is called division by primes. So we want to write both of those down. The factor tree, it looks like this. So this is a factor tree for 420. So write down factor tree and this example. So factor tree, we break it down into the factors of 420. So 10 times 42, but 10 and 42 are not prime, so you have to break them down into their prime numbers. 10 is 2 times 5, so that's prime. 42, 6 times 7, 7 is prime. Then you break 6 down into 2 and 3. The numbers that are circled, those are the prime factors that when you multiply them all together, you will get 420. So this is called the prime factorization of 420. The next method is going to be division by primes. So let's look at that. Okay, this is called division by primes. So what we do is we write the number in a division box and we divide by the smallest prime number that is a factor. And then we keep dividing until we get the answer as a prime number, or until you get 1. Sorry, you keep dividing until you get 1. The divisors are the prime factors of the number. So write that down, and we need this example in our notes. So this is what we do. We take 420. So I'm going to actually do it over here. So you take 420 and you think of a prime number that you can divide by. You can divide by 2. 2 goes into 420. 2 goes into 4 twice. And then 2 goes into 2 once. And then 0. So 2 times 210 makes 420. Now I take and put 210 inside the box and divide by 2 again. When I divide by 2, I get 105. Then I can divide by 5, but this one says 3, so I'll divide by 3. When I divide by 3, 3 times goes into 10 3 times, and then you get 3 times 5 is 105. 3 times 35 is 105, and then you're left with 5, and then 7, and then you can only divide by 7 after that. So these are called this is called division by primes, and these are the prime factors, and you write it as the prime factorization like that. Alright, so let's do example 4, which is going to be right here. It says write the prime factorization of each number. Alright, so write the prime factorization of each number. Example 4, write that down. And then let's do a factor tree. because I like that the best. So 30 can either be 3 times 10 or 5 times 6. I'm going to do 3 times 10. And then I need to break 10 down into 2 times 5. So that would be the prime factorization of 30. So the prime factorization of 30 is equal to 3 times 2, that makes 6, times 5, which makes 30. Now I'll do B, 81. So I know that 9 times 9 is 81, and each of the 9s breaks down into 3, and the 3's are prime. So the prime factorization of 81 would be 3 times 3, that's 9, times 3, which is 27, times 3, which is 81. And we've already done 420, so we're not going to do that again. So that's example 4. Now let's look at example 5. All right, example 5 says, write the prime factorization of 100 and of the square root of 100. Well, I'm going to do division by primes just because we haven't done one yet. So I'm going to take and divide 100 and do division by primes. So what prime number goes into 100? I know that 2 does. Well, 2 times what makes 100? That would be 50. Then divide 50 by 2. 2 times what makes 50? That'd be 25. And then I know that 5 times 5 makes 25. And then I can only divide by 5. So remember, keep dividing until you get 1. So these are going to be the prime factors of 100. So 100 is equal to 2 times 2 times 5 times 5. Now it says find the prime factorization of the square root of 100. Well, the square root of 100 is equal to 10. So the prime factors would be 2 and 5. So the prime factorization of the square root of 100 is equal to 2 times 5. All right. Our last example is here, and it says we can use prime factorization to help us find the greatest common factor of 2 or more numbers. So this is important, so write this example down. It says example 6, write down the question. It says write the prime factorization of 36 and 60. Use the results to find the greatest common factor of 36 and 60. So we're either going to use a factor tree or division by primes, and they've kind of already done it for you. So the first thing you want to do is use the factor tree or division by primes and find the prime factors. Now you list the factors. So 36, these are the factors of 36, 2, 2, 3, 3. These are the factors of 60, 2, 2, 3, and 5. Now we see that 36 and 60 have shared factors. So you want to circle the ones that are shared. That means this has a 2, another 2, and a 3. So circle the shared ones. And then we multiply the shared factors together. The shared factors are 2 times 2 times 3, which makes 12. So the greatest common factor of 36 and 60 is 12. So again, find the prime factors of each number, identify the shared factors, then multiply the shared factors together, and you'll get the greatest common factor. All right, I believe that's our lesson for today. So I hope you have all of this written down. If you need to rewatch it, you can. Have a great day.